This is an example of an environment in which Metaswitch network software components could be deployed to deliver a multimedia communication solution. There are 3 racks of 4 servers, each capable of supporting a number of virtual machines. VMs already in use by other data center applications, or VNFs, are represented here by grey circles.
While the Virtualized Infrastructure Manager, or Cloud OS, you will see in the demo is standard OpenStack, the management and orchestration is performed by Metaswitch software developed specifically for the purpose of demonstrating our VNFs and is represented by the shark logo. The last management component of this infrastructure is the Metaswitch Distributed Capacity Manager, our commercial system-wide session-based licensing server.
When we launch the demo, the orchestrator automatically deploys the minimum subset of virtualized network functions required to deliver the VoIP phone service. The perimeter session border controller is decoupled into separate media and signaling components. The MSC uses a medium VM flavor, while the SSC employs a large VM. The Project Clearwater open source IMS core has 2 components, an SCSCF called Sprout and an HSS mirror component called Homestead, which provides a minimal subset of registrar services. Both of these use small VM flavors.
Running alongside these components, the MetaView Service Assurance Server is employed to deliver real-time, proactive analytics and diagnostics, monitoring all aspects of the communications service. Once the components are instantiated, we will launch a traffic generator which utilizes SIP-P to simulate increasing and decreasing loads to the system.
We start off with the low call volume, which is easily handled by only 1 instance of each component. The load generator steadily increases the number of calls going through the system, and after a short while, the CSCF component of the Clearwater IMS core reaches a predefined VM utilization threshold. This is communicated via OpenStack to our orchestrator, which signals a new VM to spin up. Utilization across the resulting cluster is now used to make future scaling decisions.
The load continues to increase, and as additional media processing capacity is required by the MSC component, the system goes through the same spin-up process. These clusters continue to dynamically scale up until the traffic load starts to decrease. As these clusters cross predefined low utilization thresholds, the orchestrator will quiesce a VM and then spin it down accordingly.
Okay, now let's see the demo in action. First, we look at the network topology view on our OpenStack dashboard. There are 3 infrastructure components running. They are the licensing server, DCM, our demo Mano layer, and the Metaswitch Service Assurance Server. The system will remain in this state until we start the VoIP phone service. To do so, we go to the Mano interface, and from the Catalog tab, we have the option to launch it.
On the Deployed Solutions tab, we can see the initial Clearwater Core and Perimeter components spinning up, which is also reflected in the OpenStack interface on the right. While we have the option to add and remove nodes manually, we will go ahead and set these functions to scale up and down automatically.
Now that our phone service is in place, we can launch the test load service from the Catalog tab. Back on the Deployed Solutions tab, we see the first load generator node instantiating and 3 graphs appear on the right hand side of the screen. The top graph shows the number of calls the test service is generating. As we run through the demo, each node delivers up to 200 active calls at a rate of 36,000 busy hour call attempts.
The next 2 graphs show both the number of nodes currently deployed along with the load on that particular cluster. In the case of the MSC, this is measured by concurrent media sessions, and on the Sprout CSCF, the graph tracks the average CPU utilization required to support the signaling load.
We will now increase the number of calls by adding more load generators. As we do so, the CSCF function reaches the predefined CPU utilization threshold of 40%, at which point our orchestrator begins the process of spinning up a new node within the cluster. The same process happens when each MSC instance reaches its threshold of 500 media sessions.
This continues until the load stabilizes or decreases, as it's starting to do now. Let's watch as the orchestrator reacts to the reduction in number of calls and quiesces and terminates CSCF and MSC capacity accordingly. Once again, we see this reflected in the network topology view of the OpenStack dashboard.
With this simple demonstration, leveraging standardized infrastructure, we have now seen how network operators can rapidly turn up complex network components to deliver innovative, on-demand services with dynamic capacity scaling. The promise of NFV realized with the Metaswitch portfolio of virtualized network functions.